Lesson 3-3, transforming linear functions. So basically, transforming basically means changing or moving the linear functions. So let's start with the most basic, y equals x. Okay, so when y equals x, this is your straight line that goes horizontally. It looks like this. Okay, and the way it works is when you plug in 0 into f of x, right, your output is 0. When you plug in 1, you get 1. And when you plug in 2, you get 2. So these points are 0, 0, 1, 1, 2, 2. And this is basically the original line. We call it like the parent function. This is the most basic linear function. F of x equals x. Now, we can change it. If we change the number in front, normally we call it the slope, it'll change the way the line looks. So instead of being just a normal line going across, the slope will change the direction a little bit. So if we're starting at 0 and it goes up 1, 2, 3 over 1, your line will look like that. If the slope is 1/2, it'll go up 1 over 2. Your line will look like this. And when you compare these lines to this line, you see that it changes. So this one, the 3x, became steeper. The 1/2 kind of went a little bit lower. Okay. Now, if you have a negative, like we have here, negative 4x, that slope would go down 1, 2, 3, 4 over 1. So your line would go like this. Okay. Your line would look like that. And what was a line that has a positive slope now is going downward. So by multiplying, you're transforming the line, changing the direction it goes. So if you're changing the front of it by multiplying, you're changing the direction. Now, another way to change it, now let's use that negative 4x as our example. Okay, so we know what it looks like. It looks like this, right? Negative 4x looks like that. But here, we see that now they're taking a number and they're adding it to the end of x. There's a number here at the end of the function. So if we look at this one, negative 3 means we would start here, 1, 2, 3. But the slope is still negative 4x, so you would still count 1, 2, 3, 4 over 1. So you still have the same slope as that first line, but it's been moved downward. Right here, you have 1.5. So 1, 2, 1.5 would be right here in the middle, but your slope is still negative 4. So you're going to go 1, 2, 3, 4 over 1. So your line still goes down. You still have a negative slope. Now let's compare that. Okay? The original point was 0 in the middle, but now when you add a number to the end that's negative, it moves it down. But if you add a number that's positive, it moves it up. So when you see this at the end of a linear function, you're going to naturally see what we call a vertical translation. So basically, a translation is when you move an object up, down, and left and right. When you're adding or subtracting a number at the end, you're moving it up and down, vertical. Okay? It just depends if the number is positive or if the number is negative. Okay? Now, for example, number 2, let's take a different line, this one. So my function is negative 2x plus 4. So you start at 4, 1, 2, 3, 4. Your slope is down 2 over 1, down 2 over 1. That's the original line. Now what we're going to do this time is we're going to put a number not at the end, but with the x. So what you're going to see here is the x is now being added or subtracted with a different number. The -2 and the 4, those numbers are not changing. Only inside with the x is changing. So let's take a look at what happens here. So for this one, the line that we have that was originally going this way, when you see a -5, here's the weird thing that happens. The original line was right here. Okay, here was the original line. It's going like that. Okay. When you see this, it's going to move the line 1, 2, 3, 4, 5 spaces over. So 1, 2, 3, 4, 5. So if you move the line 5 spaces over, your line is now over here. Okay, that's what happened. So it moved it to the right. This moved it to the right. All right, now here, when you see plus 3.5, they're adding 3.5. Now remember, the original line was here and here. So it goes like that, okay? What's gonna happen here, it's gonna move to the left 3.5 spaces. 1, 2, 3 and a half. 1, 2, 3 and a half. So now my line is over. Oh, I just missed that point. My bad. I apologize. But the line will look like that. This one got moved to the left. So this is very strange. The minus sign moved it to the right, but the positive sign moved it to the left, which isn't what you expect. You wouldn't expect that because you would think positives go to the right and negatives go to the left. So to prove it to you, I have a couple of points here. If you plug in 0 into here, right? If I'm going to plug 0 into the function, you get -5 times -2 would be 10 plus 14. So 0 and 14 would be way up here. So your starting point would be up here and your line is going this way because it has the same slope. If we plug in the 0 in here, you get -2 times 3.5 because if you plug in 0, nothing's going to happen right there. You get -7 plus 4, you get around -3. So somewhere down here, which is where my line should cross. And it's just because I drew it badly, it doesn't show up, but that's where it's crossing the line instead of up here at +4. So you see that it kind of moves the points in a different way. It doesn't do it the way you expect. Now you could plug in the points. You can keep plugging in the points and seeing what coordinates you get. So like I told you, you get 14. If I plug in a 1, I think I get -8, and then plus 4, you get 12. Then I get 10, and then I get 8. And if you keep graphing it, you'll eventually see that the points match up with the drawing. Same thing here. If I plug in these points, you're going to see, okay, I got a -3. The next point would be -5. The next point would be -7. And you would see that the points line up. So you could use the table to graph the new line. But if you know the transformation, if you know what this does, it's a lot faster to see what happens to the picture. And we call this one, this is a horizontal translation, where it goes left and right. And the way you know it's horizontal is if the number that was being added or subtracted to is just in the x. So normally you'll see parentheses, and you're going to see the x is being directly affected either by adding to x or subtracting from x. But the other numbers will not change. That's when you have this. Now the last one I want to show you is when you see the slope, but you see it as a decimal, okay? How do you deal with these problems? So what we do is, when you see it in parentheses, you have to distribute. So if you distribute, you get negative 0.5 here. So here's the function for that one. And then 0.5 is your starting point, so somewhere right here. Now slope, what do you do with the slope? Go to Desmos. You go to Desmos and say, okay, what is 0.5x as a fraction? So you will get this as a fraction. So that way you know what the slope looks like. So it's 1 over 4, up 1 over 4. So it'll be somewhere over here. Because this was 0.5, it wasn't exactly at 1. It doesn't go all the way to positive 1. It goes like that. So that's what I recommend you do if you have a decimal for a slope. Right here, same thing. Now this one is not multiplying the whole thing. This one had parentheses, which is why you had to distribute. You multiplied them both. For this one, you just have to turn this into a fraction. 0.5 is 1/2. So we can graph this one. So negative 2, 1, 2. The slope is 1/2, up 1 over 2. Your line goes like that. Okay, so just be aware when they change the number in the front using the decimal, just know if they want you to distribute, you'll see parentheses. But if you don't see parentheses, it's just affecting the x. And that's really it. Transformations.